This video is about the brutal geological war that was fought to build the Panama Canal. A story completely erased by the clean, official narrative of simple engineering triumph. The official story of the Panama Canal is one of American ingenuity and concrete locks. But the true account lies in the 9-mile Culebra Cut, a war fought not with blueprints, but against a geology so violent it borders on science fiction. The first check in any real-world audit is to place the public relations story directly against the ground truth survey data. Be honest. The historical geological surveys of the Isthmus, which were available then and are still available now, showed a chaotic mix of volcanic rock, dangerously soft shales, and clay that resisted any predictable engineering model. So why does the official narrative present this as a straightforward, if large, construction project, when the very ground itself was a variable they could not solve for? We are told American engineers excavated approximately 177 million cubic meters of material. A number so vast, it feels abstract. The critical detail, however, isn't the total volume. It's the composition of that volume. The project's own core samples and daily excavation logs read like a catalogue of engineering nightmares. Think. One swing of a steam shovel's bucket could strike rock hard enough to shatter its steel teeth, and the very next swing, just feet away, could plunge into a supersaturated clay that had the consistency of axle grease. You cannot cheat the constraints of your material. So how do you possibly create a reliable project schedule when the primary variable, the Earth itself, changes every few feet? The Culebra Cut's geology wasn't just difficult. It was a series of distinct, layered traps. One of the most vicious was the Cucaracha Formation, a layer of clay and siltstone infamous for its instability when wet. A cross-reference of the project's rainfall data with the landslide reports reveals an immediate, terrifying correlation. Every major tropical downpour was a potential trigger for a catastrophic slide. Look, the engineers weren't just digging. They were in a race against the weather, knowing that a single storm could undo months of work in a matter of hours. The material itself became an active enemy. How can you call it simple excavation when the ground beneath your feet could liquefy and flow away without warning? Then there was the volcanic rock, the backbone of the continental divide. In a normal quarrying operation, you blast rock and it breaks along predictable fracture lines into manageable pieces. The project's blasting logs, however, when paired with the medical reports, tell a different story. The volcanic basalt and andesite here didn't fracture. It shattered into razor-sharp, glass-like shards. These shards would slice through the thick rubber conveyor belts used in some areas, and more importantly, they posed a constant, lethal threat to the thousands of workers drilling the blast holes and clearing the rubble. Reality does not care about your plans. Does the sanitized story of moving Earth account for a reality where the very rock you were blasting was actively trying to shred your equipment and your workforce? The equipment of that era was simply not designed for this kind of geological chaos. A steam shovel is a powerful but specialized machine, optimized to work efficiently in either soil or rock, but not both at the same time in unpredictable, alternating layers. The maintenance logs and equipment failure reports from the Isthmian Canal Commission are a testament to a constant, brutal battle of attrition. Gears were stripped by unexpected rock intrusions that the shovel operator couldn't see. Structural booms were cracked by the shock, and entire multi-ton machines would get swallowed by mud that had zero structural integrity to support their weight. This wasn't orderly excavation. It was a scrapyard in the making. What breaks first is always the part least able to handle shock. So does the clean story of triumphant machinery account for a reality where the landscape was actively trying to break their tools? The sheer violence done to the machinery meant that the Panama Canal project became a massive logistical consumer of steel and parts. An audit of the shipping manifests for materials sent to the isthmus reveals a constant, desperate stream of replacement parts. Gears, cables, bucket teeth, even entire new booms and engines. Think about the bottleneck. A single disabled steam shovel didn't just stop one part of the job. It could halt an entire section of the cut, backing up the spoil trains and throwing the whole intricate schedule into chaos. This wasn't a matter of simple repairs. It was a continuous, high-stakes rebuild of the entire machine fleet in the middle of a jungle. How can the narrative of a smooth-running industrial machine be squared with the evidence of a project that was devouring its own tools? Look at the sheer scale of moving 177 million cubic meters. We have to ground this number to understand the violence of the work. A simple volume calculation shows it is enough material to build a wall dozens of feet high, stretching from New York City to San Francisco. Now, consider that every single cubic meter of that, every rock, every shovelful of mud, had to be drilled, blasted with thousands of tons of dynamite, scooped up by a steam shovel, loaded onto a rail car, and then hauled for miles through a dense, unforgiving, and collapsing jungle. Think. The physics of this operation are non-negotiable. This wasn't a construction site. It was an industrial operation on a scale that rivaled a continental war. So does the simple word excavation truly capture the brute force industrial warfare required to achieve this? The material itself was an active enemy, not just a passive obstacle. Colleagues, any practitioner who has worked with difficult geology will tell you this. The clays, in particular, were a nightmare that went beyond just being soft. They were so thoroughly soaked by the constant tropical rains that they became hydrophobic, literally refusing to be drained of their water content. An examination of the engineer's notes on soil mechanics shows their repeated, failed attempts to de-water these sections. Be honest. It was like trying to dig a trench in a river of mud that was constantly flowing back into the very hole you just dug. How can we accept a simple story of engineering victory when the daily reality was a fight against the fundamental, hostile nature of the local geology? This is where the deception of simplification really takes hold. It's not a conspiracy theory. It's a forgery of narrative. The official story is one of men moving Earth. The reality, which is documented in the chief engineer's frantic internal letters to Washington, is of men fighting a mountain that was geologically alive and actively resisting them. Stop buying it. The project managers couldn't write, "We are losing a battle against geological chaos," in their public reports to Congress, who held the purse strings. No, they had to reduce the entire chaotic war into a single, clean, victorious number: 177 million cubic meters. But that number is a lie, because it hides the desperation, the improvisation, and the sheer, unending violence of the work. Does a single, sterile number adequately represent a war where the enemy was the planet itself. Now, let's pressure test a specific claim that often gets twisted into a mystery: the terraced or benched appearance of the Culebra Cut in so many of the construction photographs. Some people look at these images and see evidence of a vast, ancient, pre-existing structure that the Americans simply uncovered. This is a complete fiction, born from a failure to understand the absolute constraints of the work. Do the simplest check. Find the archival survey photographs taken by the French and early American teams before the main excavation began. You can then overlay the original ground profiles from those initial surveys onto the mid-construction photos. The result is undeniable. The so-called ancient terraces are simply not there at the start. So if they were not uncovered, where did they come from? The answer is a direct and necessary consequence of the technology being used. The terraces were not discovered. They were manufactured by the Bucyrus Erie steam shovels themselves. Think about the physical constraints of the job. You cannot dig a 9-mile-long, nearly 500-foot-deep trench straight down with early 20th century equipment. It is not only impossible from a machinery standpoint, it is suicidal from a safety standpoint. The unstable walls would collapse instantly. The only practical, safe way to dig that deep into that kind of material is in stages, or benches. A steam shovel would cut a level path for itself, and railway tracks would be laid right behind it to haul away the spoil. Then, the track-shifting crews would move the tracks over, and the shovel would step down to cut the next level below it. You can see this exact process documented in the project's own weekly progress photos. What looks like ancient geometry to an untrained eye was just the messy, temporary industrial footprint of their own construction process. So how can a documented, necessary, and logical construction method be mistaken for a prehistoric mystery? This isn't a secret. It is a fundamental principle of large-scale excavation that any mining engineer would recognize immediately. A forensic audit of the engineering plans, even the early drafts, shows these benches were part of the design from day one, not as a final aesthetic feature, but as a temporary, brute force necessity for the process itself. Reality does not care about your fantasies of ancient civilizations. You have to manage the angle of repose to prevent a total collapse of the walls, and you have to create flat, level surfaces for your spoil removal railway to operate on. Terracing is the only solution that meets both of those non-negotiable constraints. A simple cross-reference to any other major open-pit mine of that era, from the Bingham Canyon copper mine to the Iron Ranges of Minnesota, will show the exact same terracing effect. It is the standard industrial signature of the technology. How can an obvious and necessary construction artifact be spun into a story of an ancient, unknown civilization? Let's be blunt. The entire claim of ancient, pre-existing terraces is nonsense. It is an interpretation that requires you to actively ignore the mountain of photographic evidence, the project's own detailed engineering plans, and the basic laws of physics and soil mechanics. You can literally create a time-lapse using the dated project photos that shows these terraces appearing one by one as the excavation proceeds deeper and deeper into the earth. They are not being revealed from above. They are being created from above. You cannot cheat the evidence trail. The evidence for this is pristine, unbroken, and it points directly to the Bucyrus Erie steam shovels that were photographed in the very act of creating them. Does the presence of a known, documented, and necessary industrial artifact point to an ancient mystery, or does it point directly back to the 20th century builders who made it? So if the geology was not a mystery, and the terraces were not ancient, we have to pivot to a much harder question. What was the motive for the simplified story we are told? Think. If you are in charge of the most expensive, ambitious, and politically sensitive engineering project in modern history, you have two narrative choices. You could invent a story about uncovering ancient secrets. It is a romantic tale, but it actually diminishes your own incredible achievement. It frames your nation as restorers, not creators. Or you could tell the truth, that you waged a brutal, decade-long war against a geology so hostile it had already defeated another world power, and you won through sheer force. Which story serves your purpose better? The answer becomes obvious when you check the geopolitical constraints of the time. The second story, the true story of conquest, allows a rising nation like the United States to project an image of supreme technological might and an unstoppable national will. By demonstrating the ability to conquer any natural obstacle, no matter how formidable, you are sending a clear and unambiguous message to every other nation on Earth. Look, the construction story itself becomes a powerful geopolitical statement. It's a testament to raw industrial power. The constraint check is simple. Which narrative better served the interests of a nation trying to establish itself as a global superpower? The one about finding old ruins, or the one about taming a continent through sheer force and treasure? Reality does not care about romance. It cares about power and leverage. The narrative of conquering the jungle, of eradicating yellow fever and malaria, and of literally carving a path through the continental divide, was a brilliant and carefully crafted piece of national branding. An audit of the public relations materials and the newspaper articles dispatched from the Canal Zone during that decade would confirm this instantly. The focus is relentlessly on American machinery, American engineers, and American determination. They were not just building a canal, they were building a legend. And that legend had to be about their singular victory over nature, not about digging up somebody else's ancient work. So which story is more probable? A vast, elaborate conspiracy to hide a discovery, or a calculated, overt campaign to advertise a national achievement? This entire project was framed from day one as a matter of national redemption. Remember, the French had failed spectacularly just a few years earlier, defeated by disease and the very same impossible geology. The American effort was a direct response, a public demonstration that their system, their technology, and their political will were superior. You can cross-reference the project's internal correspondence with its public statements and see a clear, disciplined effort to manage this narrative. Every small victory over a landslide was highlighted in press releases. Every engineering breakthrough was documented, photographed, and promoted. They were consciously writing their own epic in real time. Who benefits from a story about ancient builders? Absolutely no one involved in the project. Who benefits from a story about modern man taming a savage primordial wilderness? The people signing the checks and the nation they represent. Now let's get into the central logistical problem, the part of the official story that, on the surface, seems the most unbelievable. Spoil removal. Forget the digging for a moment. The real bottleneck in any massive earth-moving project is getting the excavated material out of the hole and far away. The absolute key to the entire operation was the Panama Canal Railway. We are told this railway moved millions upon millions of tons of rock and dirt out of the Culebra Cut. But this wasn't just a simple track running from point A to point B. Be honest. It was a massively complex, constantly moving conveyor belt of hundreds of trains running 24 hours a day, 7 days a week, inside a narrow, collapsing trench. The sheer choreography of it sounds like an impossible fiction. But you can verify it. The numbers have to line up, or the entire official story is a lie. A cross-reference of the claimed daily excavation rates from the steam shovels with the known capacity and timetables of the railway system shows that it was, just barely, possible. The logistical choke point of moving the spoil was the single greatest challenge they faced. The Culebra Cut was a narrow, confined, and extremely dangerous space. At any given moment, there were dozens of massive steam shovels digging on multiple terraced levels, and each one needed a constant, uninterrupted supply of empty rail cars to be spotted for loading. A single derailed car, a single delayed train, could trigger a cascade failure that brought the entire multi-million-dollar operation to a screeching halt. How can a system so fragile possibly function on this scale without constant failure? This is the component that breaks first in a project like this, the logistics chain. The fact that it did not completely break is the real and often overlooked engineering marvel of the Panama Canal. A deep dive into the railway's engineering and operational records, which are incredibly meticulous, shows it was solved with an unprecedented system of scheduling, dispatching, and, most critically, track shifting. They had entire divisions of workers whose only job, all day, every day, in the tropical heat and rain, was to physically pick up and move the railroad tracks to keep pace with the shovels. Think about that for a second. The tracks themselves were not static infrastructure. They were a fluid, moving part of the excavation machine. You can see it clearly in the photographs. Temporary, rickety-looking tracks laid on loose dirt, curving right up to the buckets of the shovels. Stop buying the simple story that this was just a railroad. It was the circulatory system of the entire project, and it was constantly being rebuilt in real time. So does this reality of a frantic, constantly moving rail network support the idea of an orderly project, or one of barely controlled chaos? Be honest with yourself. The system they designed was absolutely insane. At the peak of operations, a train loaded with tons of rock and mud was leaving the Culebra Cut every 90 seconds. These were not small trains. They were long lines of Lidgerwood flat cars, each carrying tons of material, all headed for dumping grounds miles away. An analysis of the railway's operational plans reveals a level of command and control that was military in its precision and its ruthlessness. They had to manage inbound trains carrying supplies, coal and water, outbound trains filled with spoil, and passenger trains for the thousands of workers, all on a constantly changing network of temporary tracks inside a collapsing ditch. It is a logistical miracle that sounds impossible on paper. Yet the numbers hold up. The tonnage they claimed to move per day aligns with the known capacity of the system they built. So does the fact that this logistical nightmare actually worked make the official story less believable? Or does it make the real achievement even more staggering? At the peak of operations, over 160 trains a day were hauling spoil out of the 9-mile Culebra Cut alone. An audit of the system's design reveals the genius was in redundancy and rapid repair. They didn't just have one main line, they had a complex system of double tracks, sidings and crossovers. that allowed traffic to be rerouted almost instantly around any problem, like a derailment or a small slide. You cannot cheat the need for a clear path. They employed huge gangs of labourers whose sole job was to re-rail cars and repair track, often in minutes. The whole system was designed with the expectation of constant failure. It was robust not because it was perfect, but because it could recover from disaster at incredible speed. Does that sound like a project where everything went according to plan? Or one that was built to withstand a state of continuous crisis? The disposal of the spoil itself was another colossal undertaking. That 177 million cubic meters of material didn't just vanish. A check of the project maps shows where it all went. Huge amounts were used to build the causeway connecting Naus Island to the mainland, to create the massive Gatun Dam, and to simply be dumped in designated areas of the jungle or the ocean, creating new land. Look, each of these disposal sites had its own logistical challenges. Building trestles out into the ocean, managing the stability of the fill for the dam. The famous Lidgerwood flat cars had a system where a plough could be pulled along the entire length of the train, wiping all the material off the side in minutes. It was an efficient but violent process. So does the story end when the material leaves the cut? Or does the evidence show that was only half the journey? The Culebra Cut is the heart of the story and the absolute core of the challenge. The official narrative says they blasted and dug it from scratch, carving a 9-mile channel through the spine of the Continental Divide. The geological record confirms this beyond any doubt. It also confirms the sheer, brutal, and horrifying difficulty of the task. This was not just digging a big ditch. Look, this was a battle against a section of the Earth's crust notorious for its profound geological instability. The rock and soil here were not solid. They were a jumbled, water-soaked stack of different formations, ready to slide and collapse at the slightest disturbance. You cannot cheat the laws of soil mechanics. This fundamental instability explains everything else that seems strange or exaggerated about the project. It explains the desperate trial-and-error attempts to find a stable slope for the canal's banks, a process that continued for years. It explains the staggering, almost unbelievable volume of material they had to remove, because a huge portion of that, perhaps as much as a third, was not planned excavation at all. You can audit the project's progress reports against its budget overruns. You will find a direct, one-to-one correlation between geological surprises, that is, massive unexpected landslides, and sudden, massive increases in cost and time. They were not just digging a canal forward. They were constantly re-digging the same sections after a mountain of mud slid back in overnight. Does this sound like a project that was in control? So what about the supposed anomalous tool marks? This is another claim that completely falls apart under the slightest pressure test. The evidence isn't hidden in some secret vault. It is in plain sight, preserved in the thousands of high-resolution, large-format glass plate photographs taken by the Isthmian Canal Commission's official photographers. These are not vague, blurry images. They are sharp, incredibly detailed documents of the construction process. And when you zoom in on the exposed rock faces in these photos, they show the unmistakable, unambiguous signs of early 20th century heavy industry. You can literally see the drill hole patterns from the dynamite charges. You can see the scrape and gouge marks from the manganese steel teeth of the massive steam shovel buckets. This is not a mystery. It is a receipt for the work done. Do the simplest check imaginable. Compare these historical photos from the Culebra Cut with photos from any other major rock blasting project of the same period, like the construction of the Trans-Andean Railway or the Moffat Tunnel in Colorado. The tool marks are identical. It is the standard industrial signature of the era's technology. Drill, blast, and scoop. There is nothing mysterious or anomalous about them whatsoever. Think. The claim of ancient tool marks is a baseless assertion, made without any reference to the known, documented, and photographed methods that were being used on the site every single day for nearly a decade. The evidence for their methods is not hidden. It is the very foundation of the official story they were so proud of. So, why would anyone choose to ignore a mountain of direct photographic evidence in favor of a complete fantasy? Let's address the landslides directly, because they were the true enemy in the cut. The most infamous of these was the Cucaracha slide, which began in 1907 and was never truly stopped. It moved for years, a slow-motion river of millions of cubic yards of earth. You can see it in the project records. They would clear material for weeks, only to have the slide surge forward again, burying the railway tracks and threatening the shovels. Be honest. This wasn't an engineering problem with a single solution. It was a war of attrition. They had to keep removing material from the top of the slide to reduce the pressure, while simultaneously dredging the bottom of it out of the canal prism. They fought this one slide for years, and it was only one of more than 20 major slides they had to battle. Does the simple story of digging a ditch account for a decade-long war against a moving mountain? The story of conquering malaria and yellow fever is a crucial and completely true part of the canal's history. It was an epic of medical science and public health that was absolutely essential to the project's success. A check of the mortality rates for workers before and after the sanitation campaigns led by Dr. William Gorgas shows a drop that is staggering and undeniable. Without that victory over disease, the canal would have been impossible, just as it was for the French. But while the world rightly focused on the heroic doctors fighting mosquitoes, the engineers were fighting a parallel war that was just as desperate and, in many ways, far less predictable. The public story was about mosquitoes and medicine. The private story, the one you find when you audit the chief engineer's internal correspondence, was about landslides. These internal letters and telegrams reveal constant, urgent discussions of geological surprises. The language is not calm, confident, or controlled. It is the language of men dealing with a relentless crisis they do not fully understand and can barely contain. They were not reporting the discovery of anomalous structures or ancient mysteries. They were reporting on the unpredictable, terrifying behavior of the Earth itself. They would spend weeks and hundreds of thousands of dollars clearing a section, only to have 1 million cubic meters of mud and rock slide back in overnight, burying railroad tracks and sometimes even entire steam shovels. This was the hidden war of the Culebra Cut. The project's daily logs are filled with mundane but telling references to slides, breaks, and unexpected material movement that were not part of any master plan. The ultimate constraint check is to compare the planned excavation diagrams from, say, 1906 with the final, as-built cross-sections of the canal. The final shape is dramatically wider, and the slopes are much gentler than originally designed. Why? Because they had to keep digging, keep widening the cut at the top, constantly chasing the landslides and desperately trying to find stable ground. They were reacting, not executing a perfect plan. This was not construction. It was a desperate, high-stakes improvisation against a collapsing mountain range. Does this chaotic reality of constant failure and reactive redesign fit the clean narrative of an engineering master plan? Be honest. The story they told the public, and, to some extent, even themselves, was one of steady, heroic, American-led progress. The reality, documented in their own private records, was one of fighting a losing battle one day, and another the next, and then another, and finally, through the sheer brute force application of an almost unimaginable budget and industrial power, they simply overwhelmed the problem. They never really solved the landslide problem. Reality does not care about your elegant solutions. They just removed more material than the landslides could put back into the ditch. They won by attrition. It is a far messier, more desperate and, frankly, a much more impressive story than the sanitized, heroic version we are usually told. So which is the more compelling truth? The myth of the perfect plan, or the reality of a brutal, ugly, and improvised victory against geology itself? Let's call the original, simplified story what it is: an epic, a national myth. The Isthmus of Panama, the story goes, was a barrier that had defeated humanity for centuries, until modern American man arrived with his machines and his will, and conquered it. This is the core truth, but it's a truth that has been polished to remove all the grit, the terror, and the constant, grinding failure. The reality is that the isthmus was a natural land bridge formed by violent, tectonic forces millions of years ago. It stood as a formidable barrier that literally separated oceans and altered the course of life on this planet. It was never meant to be broken. The 20th century builders were not restorers or discoverers. They were pioneers, pitting their era's most advanced technology and the nearly unlimited national budget against one of the planet's most formidable and geologically unstable natural obstacles. The geological context is everything. The isthmus is a geologically young, active, and weak point in the Earth's crust. It's a place of extreme rainfall and known seismic activity. A simple check of the region's geological maps confirms this. It is arguably the worst possible place on the entire planet to attempt a project like this. You cannot cheat the constraints of geology, and they were fighting those constraints, minute by minute, for a decade. So, does this context make the official story more or less believable? This brings us to the alternative hypothesis, which isn't really an alternative at all. It's just the unvarnished engineering truth. Let's label it correctly. It's the geological reality model. This model proposes that the primary challenge of the Panama Canal was not just its immense scale, but a relentless, unpredictable, and violent war against a hostile and unstable geology. It works by reinterpreting every single piece of evidence, from the construction methods to the budget overruns, through the lens of geological instability and the limitations of early 20th century technology. It fits the constraints of the evidence perfectly, because it explains the massive cost overruns, the constant delays, the terraced appearance of the cut, the visible tool marks, and the staggering final volume of excavated material as direct, logical consequences of this geological war. This geological reality model accounts for all the evidence the historical and geological records provide, without needing to invent any hidden histories, ancient mysteries, or elaborate cover-ups. The terraces were a direct result of their own digging methods. The tool marks were from their own drills and steam shovels. The insane volume of excavation was a direct result of fighting endless, soul-crushing landslides. Stop buying the simple story. The story told in the internal documents of constant crisis and improvisation perfectly matches the physical reality of trying to build on a collapsing, geologically active site. The truth, as is so often the case, is far more complex and far more impressive than the fiction. The official story isn't a lie, it's just profoundly insufficient. It's a forgery of simplicity. It fails to capture the sheer, chaotic violence of the undertaking. It presents a picture of orderly, planned progress, when the reality on the ground, documented in their own records, was a decade of barely controlled chaos, punctuated by moments of sheer terror. The project succeeded not because of a perfect, elegant plan, but because of an industrial-scale application of brute force, backed by a national will that simply refused to accept failure, no matter the cost in money, material, or human lives. The real story isn't about the canal they planned to build, but the canal they were forced to build by a mountain that refused to cooperate. The verdict is clear. After a forensic audit of the project's own records, the photographic evidence, and the geological realities, the simplified, clean narrative of the Panama Canal's construction is a fiction that fails to explain the evidence. The project was not the orderly execution of a brilliant plan. It was a brutal, ugly, improvised war against the raw power of nature itself, fought in a place that was actively trying to tear itself apart. The final monument is not just a testament to engineering prowess. It is a monument to a victory, won by sheer attrition against the planet itself. If you appreciate this kind of forensic breakdown, subscribe for more.